Hi everyone! In this video we're going to sketch the graph of the given rational function. First we're going to identify all asymptotes that the graph of this function has. If you feel like you need more detailed review on how to identify the asymptotes, please watch the previous video. We're going to start with the vertical asymptote. It occurs at values of x that make the denominator equal 0. In this case, x equals 1 makes this denominator equal 0, so that's going to be the vertical asymptote of the graph. Next, the horizontal asymptote. Since the degree of the numerator is 1 and degree of the denominator is 1, in other words, they're the same, the graph will have the horizontal asymptote, and it's going to have the following equation. Y equals, and then I take the leading coefficient from the numerator, which is 1, and put it over the leading coefficient of the denominator, which is also 1. So the horizontal asymptote is y equals 1. If it happens that a graph has the horizontal asymptote, it's always good to check if the graph is going to cross it, because it's possible, and knowing that fact will be very helpful for understanding the behavior of the graph. To check if the graph crosses the line y equals 1 or not, we just have to plug 1 into the function for y. Well, y is the same as f of x, so that's where we're going to place 1. And then we're going to solve the resulting equation. If that equation has solutions, then those solutions will tell us where the graph crosses the line y equals 1. Here I placed y with 1, and now to solve this equation, I'm going to multiply each side by x minus 1 to clear the denominator. This results in x minus 1 equals x minus 3. And if I attempt to combine x's on one side, then they all cancel. And I'm left with negative 1 equals negative 3. I no longer have variables in this equation, and the resulting statement is obviously false, which means that this equation has no solution. And for us, this means that the graph of the given function is not going to cross the horizontal asymptote y equals 1. And finally, the oblique or slant asymptote. Since the degree of the numerator is not 1 more than the degree of the denominator, the graph will not have an oblique asymptote. So we found one vertical and one horizontal asymptote, so let's grab them. So this is the vertical asymptote x equals 1 and the horizontal asymptote y equals 1. Let's go to step 2. In step 2, we're going to find the y-intercept. For that, we need to plug 0 into the function for x. In other words, we need to find f of 0. It's 0 minus 3 over 0 minus 1, which gives us positive 3. So the y-intercept is the point 0, 3. And here's this point. In step 3, we're going to find the x-intercepts, if they exist. For that, we have to replace y with 0. In other words, we set this function equals 0 and solve the resulting equation. To solve this equation, I'll multiply both sides by x minus 1, so I can clear the denominator. This will give me x minus 3 equals 0, and I get x equals 3. So it looks like there is one x-intercept, which is the point 3, 0. Here's that point. We completed the first 3 important steps. In this process, we identified the asymptotes, we found the y-intercept and the x-intercept. It seems like I don't have much information to sketch the graph, and yes, I will find some additional points. But this is what I already know about this graph. Since we showed that the graph will not cross the horizontal asymptote, and since graph will never cross the vertical asymptote, I already know that graph will consist of 2 separate branches. One will be positioned between the asymptotes in this area, because I already have a point here. And another branch will be in this area between the asymptotes, again because I have a point here. And I know that I will not have any branches either here or here, because otherwise my function would not pass the vertical line test. Now when we checked whether the graph crosses the horizontal asymptote or not, maybe you were wondering how is it even possible, because we said that the asymptote is a special line that the graphs will never cross or touch. And now we're talking about the possibility of a graph crossing the horizontal asymptote. Well, it's because graphs approach asymptotes and never touch them or cross them, only with their end behavior. That's why it's possible for some graphs to cross horizontal asymptotes, but the ends of that graph will not either touch or cross it. We'll see examples like that. And talking about the vertical asymptote, the graph will never cross it, since the function is undefined at the values of x where vertical asymptotes are placed. Okay, going back to our example, As I said, I'm expecting one branch of this graph in this area and one is in this area, so I need to find a few more points in each region. This will be step 4. For the right-hand side branch of the graph, I'll find points at 1.5, 2, 4, and 5. And for the left branch of the graph, I'll find points at x equals 1/2, -1, and -2. Okay, so I found all these values. For some of them I just had to approximate, and now I'm going to plot these points. With the additional points that I plotted, I have a better idea of how to sketch the graph. Looks like it's gonna look like the graph of a reciprocal function. So I'm going to perform the last step and connect these points. Again, I keep in mind that ends of the graph should approach these asymptotes without crossing or touching them. And here's my sketch.